So have you ever wondered what the difference between a milliliter and a microliter was? Or how about a picometer and a nanometer? Or maybe you were watching Back to the Future. You were wondering what Marty McFly and Doc Brown were talking about when Doc said that the flux capacitor required a nuclear reaction to generate the 1.21 gigawatts it needed in order to make time travel possible. What the heck's a gigawatt? So today we're going to answer that question. We're going to talk all about unlocking your first chemistry superpower, metric prefixes. So whether you're calculating drip rates or you're measuring medication dosages, metric units are the language of healthcare and science. But what happens when your measurements range from something super tiny, like the SARS-CoV-2 virus, to something just a wee bit larger, like the inside of the TARDIS in Doctor Who, which is bigger on the inside? That's where metric prefixes come in. So first of all, why do scientists use the metric system in the first place? Scientists use the metric system, which is also known as the International System of Units, or SI system, because it's a standardized and universally accepted system of measurement that simplifies calculations and facilitates clear communication among scientists on a global scale. Its base 10 structure makes conversions super easy, and its global adoption minimizes confusion when sharing data across different countries and different disciplines as well. It's also important to remember to use consistent units and conversion factors to avoid accidents and mishaps. For example, in 1998, NASA lost a $327.6 million spacecraft, the Mars Climate Orbiter, when it crashed and burned while landing on Mars due to a mismatch between SI units used by NASA on one onboard system with the U.S. customary units used by another system built by their contractor Lockheed Martin. Whoopsie! In healthcare, if you don't remember that 1 kilogram equals 2.2 pounds, you could overdose your patient and kill them. Or you might underdose your patient and not give them enough medication that they need. So it's super important to understand all these units and what they mean to avoid either losing an expensive spacecraft or overdosing your patient and killing them. No pressure, right? So before we get into metric and English conversions, let's focus first on the easier metric prefix conversions. These are all base 10, so they're a lot easier to remember. So we want to think of metric prefixes as short nicknames for really big or really small numbers. Let's walk through the scale first together. Don't worry, it's a lot easier than it sounds. We're going to start with tera. We use the capital T to denote this. This is 10 to the 12th power. You want to think about your computer's hard drive, which is probably somewhere on the nature of 2 to 4 terabytes. So that's 1 times 10 to the 12th bytes of data that you can fit on that hard drive. Next we go down to giga. That's a little bit smaller. Giga, giga, depending on how you pronounce it. That's 1 times 10 to the 9th power. And so we've dropped by a factor of 1,000. And so your phone probably has a gigabyte of memory storage. And of course, remember Doc Brown's DeLorean, the flux capacitor used in the DeLorean requires 1.21 gigawatts of power. Great Scott. We're going to drop by another factor of 1,000 and go to mega. That's 10 to the 6th power. Here you want to think about megahertz in a microwave, or think about when you listen to NPR. For example, here in Nashville, the NPR station broadcasts on 90.3 megahertz on the dial. So we go down by another factor of 1,000 and we get to kilo, 10 to the third power. That's like a kilogram or a kilometer. Remember, a 5K race is 5,000 meters or 5 kilometers. And of course, the Grand Ole Opry here in Nashville broadcasts on WSM at 650 kilohertz on the AM dial on the radio station. We're going to now go down to hecto. That's 10 to the second power. That also means 100. This one's not really used as often, but the Kentucky Derby is 1.25 miles long, and that's about 20.12 hectometers. Then we're going to go down to deca, and that's 10. Just want to think about a decathlon that has 10 events, right? Now we go down to the base unit, right? The base unit, this is just 10 to the 0th power. We can say meters, grams, liters, etc. Now we get smaller from here. Deci, that's 10 to the minus first power, that's 1/10. So a deciliter is 1/10 of a liter. Centi, 10 to the minus 2. That goes down another factor of 10. And let's think of a centimeter on a ruler. Milli, 10 to the minus third. A milliliter is 1/1000th of a liter. And of course, a millimeter is probably the smallest unit on most rulers that you're going to see. We now go down by another factor of 1,000, the micro, and that's 10 to the minus 6 power. A microgram is very commonly used in medications. Nano is down by another factor of 1,000, so that's 10 to the minus 9th. A nanometer is virus-like small. Then we go down to a picometer, 10 to the minus 12th power. That's smaller than small, so atoms and molecules, which you want to think about here. And of course, then we can go even further down to femto, 10 to the minus 15th of a power. And so think about molecular dynamics simulation time steps are often in femtoseconds because atoms jiggle and wiggle that fast. That's how quickly atoms move ever so slightly. So here's the easy trick. Every prefix tells you how many powers of 10 to move the decimal, right? So kilo means 10 to the third power, or 1,000. So 5 kilometers, 5,000 meters. Now let's move down a little bit smaller. Micro. That means 10 to the minus 6th. So 2 micrograms is 0.000002 grams. Interestingly enough, the prefix used, the number here, in healthcare they often abbreviate this as mcg for micrograms. Scientists will also say, use the Greek letter mu for microgram in a scientific capacity. So either one of those are often used. So also in healthcare, if we're going to be using the smaller side of this scale, because drugs are small and dosed in very small amounts, and of course the volumes of various fluids in the body are pretty small. They're not big. So let's look at a couple specific examples. Let's say you want to give 500 milligrams of Tylenol. That's going to be 0.5 grams, right? If we measure a blood sample that's 3.0 milliliters, that's 3,000 microliters. What if you're calculating a dosage in micrograms? So knowing this scale is going to help keep patients safe to ensure that they get the proper dosage. Understanding all these prefixes helps you prevent medication errors to make quick, accurate decisions. It's not just math, it's really patient care, right? So when converting from one unit to another, we can use dimensional analysis. So to do that, you need to know the correct conversion factor to use. Let's say you want to convert 2,500 microliters to liters. The first thing you're going to do is you're going to start by writing out the units that you have. That's 2,500 microliters. Let's write that down. Now, you want to recall that there are 10 to the 6th power microliters in 1 liter. That's your conversion factor. So you're going to multiply by this conversion factor, which is also kind of like multiplying by 1 because it's an equality. Remember, anything multiplied by 1 is itself. So multiply this conversion factor with the units you want in the numerator and in the units you have in the denominator. So 1 liter over 1 times 10 to the 6 microliters. This allows you to cancel out the units microliters, since anything that is both in the numerator and the denominator cancels out. Whether it's a unit or a number, it'll cancel out if it's on both sides. So 25 microliters equals 0.0025 liters, right? Now try some of these for yourself. Let's convert 7.2 kilometers to meters. 7,200 meters. And now let's convert 0.0035 liters to milliliters. And that's 3.5 milliliters. Now let's convert 1,500 milligrams to grams. And that'll give you 1.5 grams. So how did you do? If you got them all right, you're doing great. You're well on the way to mastering this chemistry superpower. I'll leave you with a fun little rhyme about some commonly used nested prefixes to help you remember the order from large to small, right? So hopefully this helps you remember. And this might be a little bit silly, but here we go. We're going to start with tera. So tera is a trillion, towering tall. Gig is a billion, still standing tall. Mega is a million, power with might. Kilo is 1,000, used day and night. Hecto means 100, not used a ton. Deca is 10, then comes 1. Now we shrink. Deci is 10th, just starting to dip. Centi is 100th, a tiny small slip. Milli is 1,000ths, like droplets of rain. Micro is a millionth, smaller than grain. Nano's a billionth, now we're really low. Pico's a trillionth, too small to show. And I didn't come up with anything that rhymes with femto, sorry. But not to forget about. So I hope you enjoyed this video. Be sure to like, comment, and subscribe to my channel, and stay updated of the latest chemistry videos, and I will see you again in another video. Have a nice day.